So, good morning, one and all present here. In this lecture video, we are going to see about deadlock characterization. In the previous video, we saw about what is deadlock and what are all its system model and what is the process, what are all the resources, how a process can utilize the resources. We have seen three steps. One is a process can use the resource. A process can first it has to request for the resource and it can use the resource, and once used for the particular task, it has to release the resource for the upcoming process. Where the process which are all in the waiting state and which are all there for the utilization of the CPU. It has to be take the CPU. So, what are all the necessary conditions for in a deadlock characterization? So, what are all the necessary conditions means we have four conditions here. One is mutual exclusion, hold and wait, no preemption, and circular wait. What is mutual exclusion? Only one process at a time can use a resource. So that we have already seen in the critical section. Yes, the next one is hold and wait. A process which is holding at least one resource is waiting to acquire additional resources held by other process. And no preemption. If one process is running inside the CPU, other process should not interrupt or signal to the CPU that it can't utilize the resource. So that's what a resource can be released only voluntarily by the process holding it after that process has completed its task. And then circular wait, there exists a set of process, say P1, P2 until Pn of waiting process such that P is waiting for a resource that is held by P, and P is waiting for a resource that is held by P is waiting for a resource that is held by P. So that's what in a circular way it can utilize the resource. The next thing we are going to see about the resource allocation graph. A set of vertices V and a set of edges E will be there. If you studied in Max, if it is a graph should have vertices and edges. So the same way, V is nothing but it can be partitioned into two types. One is the set of consisting of all the active processor and the set of consisting of resource types in the system. So we have two things. One is requesting edge and assignment edge. What is request edges? The process is requesting for resource. What is assignment edges? The resource is directed to a particular process. That is the reverse case. So we will be seeing about the notations of resource allocation graph here. One is process. The process can be in the oval symbol. Resource type with 4 instances. If resource type, if I say as printer, the main square is called the printer, and inside small circles are called as the count of the printers. How many printers are there? And P is requesting for the instance of R that can be notated by like process is requesting for resource, and P is holding an instance of R which can be in the reverse order. So these things are called as the notations of the resource allocation graph. So here is a set of examples given. So the first thing is P, we have three processes, P1, P2 and P3, R1, R2, R3, R4 are resources. And the graph is now set as E is equal to P1 is requesting for R1 and P2 is already requesting R3, and R1 is holding P2, R2 is holding P2, R2 is holding P1 and R3 is holding P3. So that's what they have defined in this manner. And we have resource instances as one instance of resource type R1, second is R2, third R3 and R4, and processes we have P1, P2 and P3. So this is called as resource allocation graph, and one of the example of the resource allocation graph here. So in the next video, we will be seeing an example of a resource allocation process, graph with deadlock occurrence. Thank you.